At this moment, there are many projects teaching about and taking advantage of LLMs like ChatGPT to do new and wonderful things with storytelling, explaining, lesson writing, even assessment and advising, things large language models are good at. This is a talk about using LLMs for something they're not good at, yet. I'm Ross Higashi from the Carnegie Mellon Robotics Academy, and our goal is to use the educational affordances of robotics to create CSTEM opportunities for all learners. Our partner is Filament Games out of Madison, Wisconsin, makers of the sandbox robot building game RoboCo. Together, we're building on emerging lines of literature that suggest A. LLMs seem to be able to provide support to learners, and B. LLM assistance directly on tasks seems to help the least experienced users the most. This study of an LLM trained on the responses of a company's most effective customer support representatives, for instance, was able to help new reps learn faster, perform better, and stick around longer. And this effect was strongest for the least experienced reps. Now, robotics education tasks tend to look like this. You've got a job that needs doing. You come up with an idea for a robot that can do it. You build a prototype of that idea. You watch the prototype fail to find out what needs to be better. You fix it up, try again, and repeat. For this project, we're specifically looking at what LLMs can do on the core task of building a student's robot prototype. That's a step most analogous to direct task assistance in other studies, and lines up with reality, because in practice, the big hurdle in getting from here to here is actually here. In other words, your ability to learn engineering gets gatekept by your past levels of interest and experience building expensive robots. Could LLMs level the playing field for learning engineering process if an AI bridges gaps in nuts and bolts knowledge? But wait, LLMs are language models. They do words and sometimes pictures. How does a word machine do robots? Our answer is we use virtual robots, defined in LLM-friendly descriptive script, so they're basically made of code. And LLMs can write code, so now the LLM can write robots. And so a little under a year ago, Filament started development on Tavix, an LLM robot building assistant in RoboCo. Meanwhile, we put a question to our friends on the internet. What would you type in this box? The answer was way more than we thought. It turned out that rather than ask for a robot with an arm, people asked Tavix for help thinking about the problem, for it to follow very prompt engineered instructions to develop a solution that met specific constraints, and yes, just to solve the problem for them. We used that data to synthesize 6 general categories of requests and appropriate responses, along with a small library of known good reference designs. Today, Tavix starts every response by deciding which of those types it thinks is most appropriate. To request clarification, to give engineering process advice, to describe a robot or a library schematic, to suggest some schematics out of the library, to generate a construct, or to edit an existing construct. Here's how it works in practice.
This demo shows a user working with Tavix to complete a robotics challenge in a guided session. First, the user requests general guidance using natural language in the chat interface. Tavix provides general advice on how the user can approach the task of delivering a package to a porch, as well as suggested mechanisms and parts for a robot that can accomplish this task. Based on this advice, the user requests a simple construct of a base and 4 wheels to start building their robot. Tavix generates this base, and the user drags it into the build zone. The user then initiates an attempt at the challenge. In this attempt, the user is unable to deliver the package from the robot to the porch. Reverting to edit mode, the user requests a solution to this obstacle. Tavix suggests using a piston to push the box off of the robot. Based on this advice, the user requests a piston construct that can be added to the robot. Tavix provides a piston construct with a pincer attached. The user requests that the construct be modified to remove its default pincer and replace it with a flat pushing surface. Adding this new edited construct to the robot, the user tests and sees that the piston is not long enough to push the package onto the porch. The user deletes the non-viable construct and requests that Tavix edit the construct with a longer piston. Tavix provides another new construct based on this specification. Adding this new construct to the robot, the user is able to successfully complete the challenge.
So, the first result of our work is Tavix itself. Yes, you can build an LLM-based robot design tool, and it can handle both robot generation and open-ended support queries. Now, as to whether this type of AI assistance allows students with less experience to engage with engineering design, the study is still in progress. We're currently analyzing data from a crossover study in classrooms to see whether AI-equipped users have a smaller performance effect of prior knowledge, whether there are effects of getting AI sooner or later, or of losing AI after learning it. Due to classroom delays, data collection is still in progress and will resume after Thanksgiving break. Data available at the time of recording is from 23 high school CAD class students participating. They are mixed 9th through 12th grade group with typical levels of prior robotics experience, which is to say not a lot, with a few having done classroom robotics in the past. As students go through the game, we're automatically logging key events like opening and closing Tavix, as well as the queries they submit and how long it takes them to complete each level. With these in hand, we can estimate, for example, the effects of AI use on task completion as both main effects and interactions with key factors like prior robotics experience. Ultimately, we hope that our work will contribute to broader conversations about the role of AI in the future of work, but also in educational equity. Will AI building someday replace digital design? Maybe, but definitely not at this point. Tavix, left to its own devices, still produces head scratchers now and then. We suspect this is because AI doesn't have a strong understanding of physical space or interactions yet, which makes sense since LLMs by and large haven't been trained on those. And that could very well change over the next few years as big players such as NVIDIA go big into physics simulation training of AI models. But let's not forget the sentence that came after nobody has to write code. What's important is to learn domain expertise instead. STEM work is done with a purpose, with a context, and with a process. And it is our hope that the work we're doing will soon be helping students learn those powerful and widely applicable high-level skills, like engineering process, whether or not they grew up with access to robots.